Assalamu alaikum. My name is Anis. In my previous video, I actually forgot to explain the codes of the lab 11, 12, and 13. So, now I will be explaining the codes of the lab 11, 12, and 13. So, first of all, over here, it here is the code of the lab 11, as you can see over here. So, this is actually, in Lab 11, we implement many operators on the Quartz software, and we just checked how they work, and we just built their circuit diagram and the graphs of their outputs. So first of all, the task that we are performing on the Quartz is actually performing an arithmetic operation using programming language. So first of all, actually I have declared the variables, and then I have declared that I will be taking two variables as an input, and the rest of the variables will be output. So over here I have just assigned the value to the a is equal to 12 and b is equal to 3. Then after that, assign c is equal to, this means that the over here I'm assigning a value to the variable c which is equivalent to the a multiplication into b, which means that 3 into 12 is equal to c. Similarly, in the next line you can see that I am assigning d is equal to a divided by 3. So whatever the answer comes from dividing a by 3, that answer will be equivalent to the and will be stored in d. Similarly, in E, 12 plus addition will happen, and 12 plus 3, that answer will be stored in E. Similarly, in F, subtraction, and for G, as you can see, in G we are taking modulus. So after taking the modulus, whatever the value will come, it will be stored in G. So this is how we perform arithmetic operations in the lab 13. So the next task that we perform was actually logical operators. So basically logical operators are AND, OR, NOR, XOR. As you know that they have different circuits, and they have different equations and through which they work. Their working principle or criteria is entirely different from each other. Like AND gate is like a gate which is only true when both of the inputs applied on the AND gate are true. If one of the input is false, then the output of the AND gate will be false. Similarly, for OR gate, if one of any input is true, then the output will be true. And it is necessary for OR gate that if both of the output will be false, or input will be false, then the output will be false. So similarly, first of all, I have just declared the variables. As you can see, after that I have declared that the three variables ABC will be the input ones, and the DEFG will be the output ones. So while making a graph, as you know, I have shown you the graphs after the simulation in the screenshots while simulating it on the quarters. Those graphs will tell us that these variables are the output variables, so they will tell us the graph of the output values that are being obtained after running the program. So first of all, I have assigned the values to a, b, and c over here, as you can see. So the second thing that I am doing is actually assigning that d is equal to a and get b. So it means that if a is 2 and b is 0, then the answer will be 0. And then in the next step I am assigning e is equal to a or b, which means that if a is 1, even the b is 0, then the answer will be 1. Similarly, I am assigning f is equal to not of a, which means that it will complement the value of the a, which means that if a is 1, it will make it to 0. Then I am assigning that a is equal to or of c, which means that if both of them are 1, then the answer will be 1. And similarly, I am just taking a not of c. Okay, now I will move to the next code that we performed. The next code that we performed was actually related to the relational operators. Actually, we know that relational operators are the operators that are used to do a comparison to check if this value is higher than this or lower than this, if a is greater than this value or not. if the value of b is greater than a or not. So these are the relational operators which are used to drive any relation between two variables or more than two variables. So as you can see, first of all, I have declared the variables. Then as an input I declared the four variables, and then as output I have declared four variables too, and I have assigned the values to the input variables. As you can see over here I'm just performing the relational operators. As you can see in the first line, assign e is equal to a less than b, which means that if left a is less than the b, then it will give you the true value, which will be 1. And similarly in the second line, as you can see, if f a, assign f is equal to a greater than b, which means that if a will be greater than b, then it will be evaluated to false. Since we know that a is actually less than b, so it will give us the false value, which will be 0. Similarly, over here we are checking that if the value of a is equal to or greater than c, which will be stored in g, as we know that the value of a is 2 and the value of c is 2. So the both values are equal, so it will give us the true answer, which will be 1. And similarly in the same thing is happen. So we write the end module at the end of the program to tell that this is how the program, the main body of the program has finished. So our software quarters will know that to which line number it has to execute. Now the second thing is the equality. Actually we know that equality is are used to assign the values. Okay, there are many types of equality: logical equality and logical inequality. Okay, so if one of the operand is shorter than the other, it expand with zeros unless most sufficient bit is unknown. So over here, first of all, I have declared the variables. As you can see, I am declaring 6 variables as an input and 2 variables as output. Over here, as you can see, I have assigned value to each of the 6 variables. And in the next step, I am actually just using different equalities and performing tasks and storing those values in the other variables which have been assigned as output. Over here, as you can see, g is equal to a, equal to b, which means that if the value of a is equal to the value of b, then it will evaluates to true, and if it's not equal, then it will give us 0. Sorry about that. And similarly for h, we are first taking the not and then checking if it's equal to the d or not the value of c, and it will be stored into the h. Basically it's an logical inequality. Okay, and similarly in the next line I am also again just performing the logical inequality, and then the other one is the case of equality, which is looking that if the value of d is equal to the value of e, which is not equal, so it will give us your answer. And similarly for the k. Now I will just move to the next operator, which is our bitwise operator. Okay, so in bitwise operator, actually what we do is to perform XOR or XNOR. It is actually a negotiation. Okay, bitwise operators are basically performed on the two operands. If any of the operand is shorter, it is bit extended to the left with zeros. So what it does is actually if any operand whose values is shorter, so it will extend its bit by putting 0 at the end of that variable number. So similarly, as you can see over here, I have declared the my variables, and then I am initializing few variables as input and then as an output. Then I have assigned value to the input variables. Then I am just performing a simple task, which is assign d is equal to not of a, which is the bitwise negation. Okay, it means that if the value of the b a is equal to 1100, then it will change it to the 0011. Okay, similarly assign e is equal to a and c, which means that if any of the value is 0, the output will be 0. If both of the values are true, then the output will be 1, which means that the value of the A is actually 1100 and C is 0101. So it will give us 0001 0. Okay, and similarly for F, it's an OR logical operator, so it will give us 1 if any of the value is 1, and will give us 0 if both of the inputs are 0. Similarly, I'm just performing the simple task. This is the bitwise operator. Actually, it just changes the zeros into the 1 and ones into the zeros. It's a kind of negation, like a type of NOT gate we can see in simpler words, but it's not actually a NOT gate. And then there is a reductions operator. Actually, reductions operators are NAND, NOR, XOR, XNOR, etc. Okay, which takes the one bit by bit and performs on it. So as you can see, I have declared six variables over here: three variables as input, three as output. Okay, now I'm assigning the value to the three variables that I have declared as an input, and after that I'm performing a function on it, or performing some task on it. Okay, as you can see, assign D is equal to and A, which means that it will perform a bitwise operator and checks the value of the A variable. As you can see, A is equal to 111, so it will perform 1 and 1 and 1 and 1. If all the values are 1, then it will give us answer 1. If any of the value will be 0, then it will give us 0, because it's an AND gate being used. And similarly for OR, if any of the values 1, it will give us 1. As you can see over here, it is 0 1 0 1 0 1, so it will give 0 or 1 1 or 0 0 or 1, so it will give us 1. Similarly over here, I'm just evaluating the XOR gate. You know the logical equation of the XOR gate, so it's easy to implement. Nothing is difficult in it. So over here, actually now we are using the shift operators. Basically, shift operators are used to shift the values either to the right side or to the left side. It depends upon what kind of shift operator you are using. As you can see in this small program, we are using both type of shift operators. First, we are shifting the value towards the left, and then we are shifting the values toward the right by 2 bits. So how it is done, we will know it. First, I have declared the three variables: one variable as an input, two as an output. Then I have assigned some value to the variable A, which is 1010. Then I am performing an operation on the variable A and assigning the output of that operation to the variable B. So basically over here, what I am doing is actually shifting the value of the variable A to the left by one bit. So it means that this one over here will be shift towards the left and will become 0. This will become 1, this will become 0, and this will become 0 2. So it will be 0 1 0 0. Okay, so that's what happens in basically in shift operator. It basically shifts our value towards the left or towards the right. It depends upon the us whether we are using the left shift operator or the right shift operator. And similarly over here, this was our lab tasks. Okay, now I will just move to the next one, which was actually about multiplexer and implementation of multiplexer using different method. Actually, there are three different methods through which we can implement a multiplexer. As we all know what a multiplexer is. Okay, so we will just move towards the course of method one is using gate level implementation, which means that we can implement a multiplexer using logical gates. Okay, which is quite interesting because multiplexer is a very useful thing and it helps us a lot. So over here, as you can see, that first of all what we have done is actually